Dear students, this is a rather small lecture on component diagrams from the UML set of diagrams. And the slides just follow a couple of pages in the textbook. And I was not in a position to write any other type of slides except the one which followed the textbook. But in principle, software components changed since the 2000, since UML allowed the notion of software component to be a UML concept, because software components were not part of the UML from the beginning. They arrived to UML rather late. So I'm now going to share the screen with you and just quickly go through these slides. They, as I said, correspond to the book. However, there are many books on software components in general, in software development, and they don't refer always to a unified modeling language. So there is some kind of discrepancy. Software components exist. They were invented as a term in 98, but UML took it as being a particular concept for modeling rather late. And since entered the UML, this notion of software component hasn't changed. However, what changed in real life, that in the last 20 years, we have component-based software technology, which helps us to create software systems which consist of software components. Okay, it's quite, in principle, confusing, but our book is not very good to explain what's happening to software components today, no. Let me just now share the slides with you so that we can go through them fairly quickly. We should know what software component is, how to find them. I have to give you a couple of examples, and you have to tell me what the purpose of component diagram is. Notion and modeling elements are not as important as you may think, because component-based software technology changed in the last 20 years. So the notion which existed 20 years ago, which probably exists in our books, is not what we have now, I'm afraid. The slides on the definition of software components is not very clear, because I refer you to go to Sibersky's book, which was published sometimes when the first version of UML was delivered to all of us. So in parallel with UML, people from the software engineering world were trying to define software components for one big reason, is that objects and classes in software development were too small to handle the volume of code we even had in object-oriented world. So we very quickly realized that in some special circumstances, objects and classes were perfect for implementing software solution using object-oriented programming languages, but that was about it. The more we started creating code using object orientation, the more problems appeared in front of our eyes. Actually, objects and classes are too small to represent the software and to illustrate the software either under development or implemented. Therefore, people started talking about bigger chunks of software being something, and they decided to use the word component. It promised us, the promise was that we will be very soon, that was said in 2000, we will be going to shops to buy software components like we go to supermarkets with a trolley, you know. So we were waiting for that. And there were at the beginning quite a lot of companies which were just selling ready-made software components. You go there, buy it, come back home, install it, and you have a complete software working for you. Please don't confuse it with software libraries, because that they had a different purpose. And you could imagine that at the beginning, we had numerous ready-made software components which were creating user interfaces. This is how it all started. Yeah. When the distributed programming changed into client-server architecture, objects definitely disappeared as a notion of software that we dealt with. And even Java programming language was not very efficient. Maybe at the beginning, I remember at the beginning, we were all just crazy about the way how software was developed through object orientation. But then very, very quickly, we were convinced that something bigger must appear. So Sipersky was selling us idea, and there is a book, you can click on the link on the previous page. The book is a very difficult to read. It's still valid after 20 years, but it's almost impossible to read it as a textbook. So I don't want you to open it and investigate it. Maybe one day, if you will be computer scientist interested in the history of software components. But the idea was, in principle, that software components deliver services to another software component. So one component says, okay, I need this service, who can give it to me? And then this software component on the other side said, okay, I have this service, and we match required and offered services. Yeah, this magic was done through software technology. And we had DCOM, J2E, .NET, and there were many, many which started even in the 90s. They were extremely complicated to understand. In order to learn the first version of J2E, you needed 5 days, so very intensive course with Sun Microsystems in order to understand the technology. Today is slightly different because we have a lot of tools. But to have a technology which will manage the software components are glued together by having delivered services and required service on the other side. Idea was perfect, but implementation through the technology wasn't straightforward because you were supposed to learn the philosophy of the technology. How do we find software components? No solution there. You can still stay with the classes and objects. Anything can be software components. A database can be a software component. Your one line of SQL can be software component. But what was very, very important, that these software components with this component-based technology starting telling us that we should layer our software components into user interface layer, computational layer, and data layer. That was the idea from the software architectural style, which was called component-based and layered. So we started developing this type of software 20 years ago, as soon as Java technology took off properly, yeah, and .NET followed after that. So we group functionality of these software components. If you have software components which will deal only with user interfaces, create interfaces, manipulate and so on, that's in one layer. So it's better that they are very close to each other in the conceptual model, not in real life, in conceptual model, so that you can probably implement these software components using the same software technology. Computational in the middle layer. It was also very famous that we keep computational components in between user interfaces and data at the top and data at the bottom. That was quite known in software construction in the past, in the history. So it's not just invention of component-based software development, but it became prevalent, so prevalent. We were talking about software as a service only through component-based software development. So after that, we had service-oriented software architecture and normally component-based and layered. It dominated for almost 2 decades and still very, very important. So how is UML related to that? It is, because do you see how sequence diagrams, we were told that the first object in your layered architecture will be user interface, which are screens, second computer program, and data. So from left to right on the top row sequence diagram, if you just turn it the other way around, you know? So what was on the left is at the top. What was in the middle is still in the middle. And what was on the right goes at the top, bottom of your component-based software diagram, which was layered. I'll talk about this quite a lot. So sequence diagram directly creates a layer, a cradle for software components which will be layered. Here is all these diagrams on software components. Do you see these little rectangular on each software component were called user interfaces, which actually connect two components together. We don't draw them anymore at all. No, our software components are very often layered into these three layers, as I mentioned: user interface, computations, and data. So this one is the most popular diagram on software components in many books, but we don't draw them anymore. This is slightly closer. This is the way we used to draw if you just want to put all your software components on the piece of paper, and they're just there. They're not layered, but they're connected with each other because you match required and delivered services. So we also try not to do that, but you might be in situation to draw this in future. You don't know. I haven't done this minimum 15 years, anything like that, because I always layer my software architecture in these three famous layers, because all my software technology can implement application out of it straight away if you do have these layers. Now, in this slide is maybe the closest we have today. I forgot where this example is from. I'm so sorry. So you have a MySQL database here as a software component, and the web server and the web browser. That's kind of a very straightforward set of software components. Do you see how one software component can be very tiny browser, maybe a big database, but web server is huge and consists of some other components. We will not be drawing this much because we will be asked in this subject to create component-based and layered software architecture, not dispersed on the A4 format, whichever way we want to. So what was the purpose of this? I think as soon as we started defining components arbitrarily in software development, technology appeared. So server technology initially, then J2EE and .NET appeared. So we immediately, because technology was there, we started drawing software components in layers. And we call it software architectural style. That's your software architecture. Must be component and based, layered and component based today. We practically stop using any other. There are some other software architectural styles and patterns embark on that. But the MVC pattern, Model View Controller, I will be talking about this in the next lecture. It is based on layers and grouping different type of components to be in the same layer. Well, component is a stereotype in UML because UML people didn't want us to have this as a particular modeling element. I think they didn't believe that we will have component-based software technology because it didn't exist. We just in those days had event-driven programmings, but event-driven programming could have been done easily at the level of classes. Classes would never be able to create conceptual model and software architectural style for every single application of the 21st century, because you can assume that when we create component-based and layered software architecture, that it can be done in any operating environment, from Windows to iOS and Android, doesn't matter, okay? So it really works everywhere. Now, what are you going to read in the book? 8.1, 8.2, and a little bit of 8.3, and that's all. There will be no questions to answer from these slides in the exam. However, and there are no exercises in the book that we will take, no. But what I'm going to do is to prepare my drawings on software components and layered architecture. And how do we get it? Because you can create component-based software architecture and model directly from sequence diagram, directly. Sequence diagram practically supply your conceptual model of software application. You find technology for deploying this model and you have an application, implementation straight away. This is a new way of modeling, okay? You practically, from the use cases, you jump in sequence diagram. Sequence diagram are practically skeletons for creating component-based and layer software architecture. There are technologies which will take this architecture and deploy its context in any operating environment, and you have directly implementation from the architectural level of your software description. And everything starts with practically use cases and sequence diagram. We will come back to the role of class diagram in component-based model. Do you see, I haven't got any drawings on that. I am not allowed to draw in these slides anything which is not in the book, because I didn't want to extend my lecture slides outside the book. This is why we will have separate drawings and separate sources of information for our workshops, where we will debate the way of creating component-based software architectures for any software application today, following the semantics discovered in sequence diagram, which are consequences of having a rich semantics in use cases. So the journey is use cases, sequence diagram, component-based, and layered software architecture. Okay, that's all. Thank you for listening. I have to stop sharing the screen and stop recording. Okay. I keep saying that my recording will be rather short, and they're never short. Okay.